In this example, we're going to be looking at net ionic equations. So this is a bit of a throwback. Net ionic equations, if we see right here, remember, are describing which compounds or which elements are involved in the reaction, because some of them are spectators. They're just watching what's happening and are not actually part of what is occurring in the reaction. So we want to be able to determine which things are involved in what we're doing and which things are just sitting there watching. So, in this case, we're going to write the net ionic equation for the following molecular equation. It tells us first that HNO3 is a strong electrolyte and that HClO is a weak electrolyte. So I'm just going to highlight my reactants versus my products. All right, so there are two important things that we have already been told. One is that HNO3 is a strong electrolyte. Recall that an electrolyte is something that breaks down into its pieces in water. It is an ionic formula that breaks down into separate ions. A weak electrolyte is also an ionic compound, but it doesn't break up as well. So because it doesn't break up as well, it still appears in the solution as a product. Okay? So when we're looking at net ionic equations, remember, we're going to be looking at which things break apart into their respective ions and which ones do not. And we can usually tell based on whether they are aqueous or solid. Okay, so let's take a look at our chemical equation here. We're told that KClO is aqueous. So because KClO is an aqueous compound, that is going to break apart into its respective anion and cation. Okay? Our next compound, HNO3, is also aqueous. So it will also break apart into its respective anion and cation. Next we have KNO3, which is aqueous, and that will also break apart into its respective anion and cation. And last we have HClO, which is aqueous, but we were given a warning about HClO that it is weak. So because HClO is weak, it will not break apart into its respective anion and cation. Okay, so if we look down and we try to break these things up into their respective anions and cations, we're going to start with our first compound, KClO, which will break apart into one K plus ion, that is aqueous, and one ClO minus ion, that is aqueous. To that, we are going to add additional ions because HNO3 breaks up. HNO3 breaks up into an H plus ion that is aqueous and an NO3 minus ion that is aqueous. All those things added together will form a new aqueous compound, which is KNO3, so that will break apart into its respective ions of a K plus that is aqueous and an NO3 minus that is aqueous. And then we said, lastly, we have our HClO3, which won't break up into its respective ions, so that remains HClO. Okay, now there's one distinction here that's going to be a little confusing, and that's because HClO was aqueous in our chemical equation. Okay, even though it says aqueous this time, because it was a weak electrolyte, it doesn't break up. But we do still need to include that symbol AQ next to HClO to clarify that it is still an aqueous compound in our solution. Okay? Now, once we've broken up all of our ionic compounds into their respective ions, we get to cancel out or ignore whichever elements or compounds are the same on the left side and the right side. So the ones that go unchanged from the beginning to the end. So if we look at what we have written down here, K plus, that is aqueous, on the left side, and a K plus that is aqueous on the right side. Because they are the same on both sides, they go unchanged, boom, we get rid of them. We have a ClO minus that is aqueous. On the right side, though, we have a ClO that's attached to an H. So that's different from what it started as on the left side. So we need to keep that there. We have an H plus that is aqueous. Over here on the right side, we have an H that's aqueous, but it's not apart from the ClO. So again, we need to keep that there. We have an NO3 minus on the left side and an NO3 minus on the right side that are both aqueous. No change there. Boom, boom. We get to cancel them out as well. So we've gone through all of our elements and compounds. So now we need to bring down which things did not get canceled out or which things were not spectators. So we write our complete equation by bringing those down. ClO minus, which is aqueous, plus H plus, which is aqueous, creates HClO, which is also aqueous. All right, and there you have our full complete net ionic equation. Okay, if you are putting that into the Cengage assignment, right here you have the blanks that are listed out as it says. In this case, we don't need a box, so we're going to leave it blank.